Hello everyone, welcome to this Kosen Physics Part 6, and you can see there's questions about charge there and Coulomb's law and everything related to that. So there's a charge A, okay, the value is 2 times 10 to the power of minus 6 Coulomb. Then there's a charge B with the value of 8 times 10 to the power of minus 6 Coulomb, okay, are located at position A and B. There's a distance L. Let's say the distance is 1.5 meters, and the proportionality constant of Kc of Coulomb's law. So that is just the Coulomb's constant, 9 times 10 to the power of 9 Newton meter squared over Coulomb squared, and yeah, round off your answers. The resultant electric field is equal to 0 at the position C. So they say that at the position C, the resultant of the electric field from this charge and this charge is 0, and we need to find the position between line AB and what is the length x. So to this question, there's a quick formula for you that you may use this. This will be help you for the future question if you face something similar with this. Just remember that x, okay, is equal to the distance between charge A and B times the charge of QA over root of QA plus root of QB. So this is 1.5 times the root of 2 times 10 to the power of minus 6 over root 2 times 10 to the power of minus 6 plus root 8 times 10 to the power of minus 6. Okay, so we can calculate this 1.5. We can just separate that. Okay, and you know that 8 is 2 root 2. So we can cross this and we cross this. So this is 1.5 over 3, 0.5 meters. Okay, so at 0.5 meters, the resultant electric field is 0. Now for number 2, we should calculate the magnitude of the resultant electric field at the position D with a distance of 0.5 meters. As you can see in the question there's a position D, right? And we need to calculate the magnitude of the resultant electric field ED at position D from the position A. The position D is located on the line AB. Right, so basically the resultant electric field from A to the position D and from the electric field produced from B to position D, we need to calculate the resultant between these two. Okay, so to do that, we could use the formula of the electric field, that is K Q over R squared, and K is the proportionality constant, 9 times 10 to the power of 9, Q is the charge, and R is the distance, right? So the value of, so we need to find the K using the charge A, and now using the charge B. And you can see that this is 9 times 10 to the power of 9. The QA is 2 times 10 to the power of minus 6 over the distance 0.5 squared plus 9 times 10 to the power of 9. QB is 8 times 10 to the power of minus 6, and the distance is 2, right? 1.5 and 2. Right, if you calculate that, the result is 32 times 10 to the power of 3 plus 18 times 10 to the power of 3. 50 times 10 to the power of 3, it is 5 times 10 to the power of 4 Newton per Coulomb. So that is the units of the electric field. Okay, so for this you just use the electric field formula and you get the answer. And now for number 3, it said that calculate the magnitude of the resultant electric potential. How to read that? Is that phi D at the position D Note that the electric potential at the infinity is taken to be 0. Okay, now it is just using the formula of the electric potential. Remember, it is different between electric potential as in the question and electric potential energy. So the formula of electric potential, right, that is kq over r for the question, but electric potential energy is kq squared over r. Okay, so we just use this formula here, and yeah, just using the same method as this. So we find A and we find B. 9 times 10 to the power of 9 times 2 times 10 to the power of minus 6 over the distance 0.5 plus 9 times 10 to the power of 9 times 8 times 10 to the power of minus 6 over 2. And you can calculate that the value is 7.2 times 10 to the power of 4 volt. Yeah. So that is for number 6, and yeah, stay tuned for the next part, and this is related to the electric field and the Coulomb's law.